Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability Exercise 5.1. So already in the last videos, we have seen the solutions up to question number 4. Now we are going to see the solution for fifth sum. Is the function f defined by f of x equal to x if x is less than or equal to 1, 5 if x is greater than 1. This is the given function and they're asking us to test this function is continuous at x equal to 0 and at x equal to 1 and also at x equal to 2. So throughout the real line they didn't ask. So randomly three real numbers they have given and they're asking us to check the function is continuous or not at three different points. Okay, so first we'll start with this function is continuous with at x equal to 0 or not. We'll find out. Now what is the given function? F of x equal to given f of x equal to x x if x is less than or equal to 1, 5 if x is greater than 1. So this is the given function. So first we are going to test this function is continuous at x equal to 0 or not. So for that, so when we test at a point, three things we have to verify. So at x equal to exactly 0, what is the function value? And if x is approaching towards the 0 from the left hand side, what is the function value? And same way if x is approaching towards the 0 in the right hand side, what is the function value? If the left hand side close values of 0, okay, and exactly 0 and right hand side close values of 0, all these three things if coincide, then we can say function is continuous. So basically we are going to check left hand limit, right hand limit and f of 0 value are same or not. If all these three results are coincide, if it's same, then we can say that function is continuous. Okay, so now first f of 0 will find out if x is exactly 0. Okay, since we are finding at one point, directly itself we can substitute f of 0. So 0 is what? Less than 1. If x is less than 1, we need to choose the first function. Then f of x equal to x means whatever input we give, same output. So f of 0 also 0. Then left hand limit. So left hand side close values of 0 also less than 1. Then obviously first function only. So limit x is approaching to 0 from the left hand side. And f of x is what? First function. So we have to replace the first function in place of f of x. Then when we apply the limit, we are getting the result 0. Now same way right hand side limit. Limit x is approaching to 0 from right side. So right side close values, no, right side very close values. Close values in the sense 0.001, not 1, 2, 3. Such values we should not take. So we have to take the values which is very close to 0. Obviously, even when we round it, we have to get the approximately 0. So such type of values only. Even right side very close values of 0 is less than 1. So obviously first function only we have to choose. So first function is what? F of x equal to x. So we have to replace f of x as a x. Now close values of 0 is approximately 0 only. So when we apply the limit, we will be considering in place of x as a 0. So when we substitute no, the limit value also that overall becomes 0. So this one 0. Now if you notice f of 0 value, left hand limit, right hand limit, all the three values are same. Here f of 0 value, left hand limit, right hand limit, all the values are same. So we can say that so f of x is continuous at 0. So continuous at x equal to 0. So first part we completed. Now also they're asking us to check At x equal to 1, same function. At x equal to 1, whether it is continuous or not, they're asking us to check. So same method only. So now we are going to check for at x equal to 1, how the function is. So now same way for 0, what we done, similar process. So when we check for at x equal to 1 function is continuous or not, we need to find out f of 1 value and left hand side close values of 1, that is left hand limit and right hand limit. All these three things, if it coincide, then we can say at x equal to 1 function is continuous. In case if all three values are not coincide, then we can say function is not continuous. Now if x equal to 1, so when x takes the exactly 1, so in the given function, which one will be the suitable? If x is less than or equal to 1. So even if x is exactly 1, we need to choose the first function. So f of x equal to x. Then f of 1 will be 1. Okay, now left hand limit. Left hand side, this way it's approaching, right? Limit is approaching from the left hand side. Left hand side close values of 1 are less than 1, right? 0.999. So when we round it, we are getting the result 1. So close values of 1 are less than 1. If it is less than 1, we have to choose the first function. So now limit x is approaching to the 1 from left hand side. Which function will be suitable from given first function? So we have to replace the f of x with the first function. Now once we apply the limit, x is approaching to 1. That means x takes the value 1. So left hand side value, left hand limit value is 1. Now right hand side limit. Limit x is approaching to 1 from right side, f of x. From right hand side, if the limit is approaches, right hand side close values of 1 is what? 1.0001. For sample, I am telling 1 point. So such type of values are greater than 1. If it is greater than 1, so whatever values lies after 1, no, it's a greater than 1. If it is greater than 1, we need to choose the second function. So in place of f of x, we need to replace 5. Limit x is approaching to 1, f of x, what function it will take? 5. So 5 is a constant function. So while applying the limit, if it is a constant, same constant is the result. So right hand side limit is what? 5. Now if you notice, f of 1 left hand limit values are same, but right hand side limit is not same. If all the three things are equal only, we can say function is continuous at particular point. But here only f of 1 left hand limit alone is the same, right hand limit is different. So here left hand limit, right hand limits are not same. So f of x is discontinuous at x equal to 1. Okay, so we tested at x equal to 0, function was continuous. And now we tested for 1, function is continuous. Now we are going to test at x equal to 2, how the function is, whether it is a continuous or not, we have to check now. Now at x equal to, if x is exactly 2, okay, then f of 2. 2 where it lies? After 1. That means it is a greater than 1. If it is greater than 1, we have to choose the second function, f of x equal to 5. So f of x equal to 5 is what? Constant function. So whatever input we give, the result is same only. So f of 2 is what? 5. Now left hand limit. Limit x is approaching 2 from left hand side. See, from limit x is approaching from left hand side, no, from the 2. Okay, if the limit approaches towards the 2, close values of 2 are, anyway it's a greater than 1 only, right? It's a less than 2, but we have a function based on the conditions. If x is less than or equal to 1, x is greater than 1. So we need to check close values of 2 is a greater than 1 or not alone, we need to check. So here in left hand side close values of 2 is also greater than 1, right hand side close values of 2 also greater than 1. So for both left hand limit and right hand limit also, we are going to use the second function only. So replacing f of x with the second function, that is 5. Since it's a constant, even when we apply the limit, same 5. 5 is the result. Now right hand side limit. Right hand side close values also for 2 is it's a greater than 1. So replacing f of x with the constant 5. Now when we apply the limit, result is 5. Now here f of 2 value, left hand limit, right hand limit, values are same. So f of x is continuous. Continuous at x equal to 2. So that's all the solution for this. So they didn't ask us to check the continuation for the throughout the real line. Function is given, we need to test for 3 different points. One is if x is 0, other one is if x equal to 1, other one is if x equal to 2. So out of this, only at x equal to 1 is the function is discontinuous, and at x equal to 0 and at x equal to 2 function is continuous only. Okay, so that's all this sum. We'll continue the next sum in the next video, and thanks for watching, and please do subscribe. Thank you.